Hello everyone. So for number 36 in part 3, we're taking a look at a kind of like a modeling question. We're going to try to represent or write an equation to model this given scenario about a soccer field, and then we're going to try to solve it. It's going to end up being a quadratic once we do solve it, so we'll keep in mind some quadratic methods, and we'll just get it started here. So whenever we deal with any type of kind of visual or a question where you're dealing with some type of geometric figure, switch up the order there, it's helpful to have a visual, in my opinion at least. I like to look at the shape I'm dealing with. It kind of helps me label things and get things going. So it has an area of 6,000 square yards, and it's a rectangle, so we'll keep in mind square yards. The formula for area, hopefully we're aware of this at this point, is length times width. And it says the field must be 40 yards longer than its width. So we can use a few different letters here. We can use X and different things like that. I'm going to use W for the width. I'm just going to arbitrarily label those as the width. So now, if the length has to be 40 yards longer than the width, and if I call the width W, how would you represent 40 yards longer than that using the same letter W? You'd represent it as W plus 40. You wouldn't want to just stick a L on there and then have length and width, because then you're going to have a two-variable equation. You don't have enough information to develop a system here. Or you could, I guess, but it would make it a lot more difficult than just solving it this way. So in our case, we're going to use our area formula to help us kind of derive the equation, which is 6,000. The area is equal to, the product of the length and width, which would be W and W plus 40. And this is where our quadratic starts, because once we distribute, right away we see a squared term, quadratic equation. Okay, so I'm going to subtract 6,000 from both sides to get this quadratic in standard form. It's a W. Let's fix that. Equals 0. Okay. Now there's a few different ways we can go about solving this. We can complete the square. We can use the quadratic formula. We can factor this using sum product. Taking a look at the product here, which is 6,000, could be a little bit difficult trying to do that. So I'm going to go about with the quadratic formula. It's up to preference. It would be easy to complete the square as well, since A is 1. Could also use your graphing calculator here if you wanted to calculate the 0. But I'm going to use the quadratic formula. So that is, from your reference sheet, negative b plus or minus the discriminant, square root of the discriminant, which is b squared minus 4ac, all over 2a. And now plugging in our labeled values, we're going to get negative 40 plus or minus b squared, which is 40 squared, minus 4 times 1 times negative 6,000. All over 2 times 1, which is just 2. So I like to type the discriminant into the calculator to give me kind of a good idea of what I'm dealing with under the radical. And my calculator pops up. So we're going to get 40 squared minus 4, put this all in parentheses, minus 4 times 1 times negative 6,000. So we're minusing this entire thing. So my discriminant is going to be 25,600, and I'm going to take the square root of it in the next step, so I might as well figure what that is now. 25,600 is a perfect square. It is 160. So that messy radical ends up working out to 160. Now, if we do the math here, we have two answers. We have a plus and minus. In this case, if we do the subtraction, we're going to get negative 200 over 2, and if this is representing the width of the field, so we should use a W up here, just to be precise. W is our variable here, not X. We would have a negative if we did that calculation, so we're only going to consider the positive route, which would give us the only positive answer here. So the negative answer is a reject. You could write it down, it doesn't hurt, and just cross it off, but we're only going to consider the positive. Negative 40 plus 160 is 120, so equals 120 over 2, which is of course 60. And our unit here is yards. Okay? So if the width has to be 60 yards, or is 60 yards, what would the length be if it's 40 more than that? What's 60 plus 40? 100. If you did some product, like we mentioned earlier, your numbers would have been 100 and negative 60. And you would have set up a t-chart. You would have got your answer that way. You would have got W equals 60 by setting, your mini equations, setting them equal to 0. But we did it kind of the more difficult way, or not more difficult, but a little bit more longer way, I guess. But the quadratic formula will always work. It's a good safety, if you're having trouble coming up with the numbers, sometimes a 6,000 can scare people away. So I wanted to show how to do it with the quad formula. Good fallback plan. And we've algebraically, we showed our work. We didn't just kind of do a guess and check. The word algebraically, they want to see what we did down here. They want to see the work. We found the dimensions. We could say, just to state it a little bit more clearly, therefore, the width of the field is 60 yards, and the length is 100 yards. You could also check there. Obviously, they have a difference of 40, and the area would be correctly 6,000 yards. 60 times 100 is 6,000. Okay? Thank you for watching, and hopefully you found this helpful.